Welcome to Best Academic TV. In this video, we're gonna focus on derivative by chain rule or chain functions. This is the third function here. Before now, I introduced the definition of derivatives or differentiation, and I told us that for us to differentiate any equation or any function, the first thing to do is to identify the function. We have treated the first one, which is monomial function, and we have treated the second one, which is a polynomial function. In this topic, we'll consider the third function, which is chain rule. So before we solve some questions here, let's know when a function is in chain function or in function of a function. You can either call this chain function or function of a function. You can either call it chain function or function of a function. Please take note. So please take note of this. To differentiate a function in this format, y equal to ax plus b all raised to the power of n. We apply chain rule, that is chain law. To differentiate a function in this format, we apply chain rule. What does it mean here? It means that whenever we have a function, and in that function, it consists of inner part, which is this part here, and outer part, which is the brackets and n, we differentiate that using chain rule. Please take note. And again, whenever an expression is in captive with a power, please pay much attention to this. Whenever you see an expression or equation with a power, either negative or positive power, we apply chain law or chain rule. Please take note. So class, how do we apply the dy dx here? To differentiate this, our dy over dx will be equal to class inner derivatives times outer derivative. Inner derivative times the outer derivative. So before we know the inner derivative, we have to know how to identify the inner. And before we know the outer derivative, we have to know how to identify the outer. Please take note. But please pay much attention to this. Inner derivative and inner is not the same. So for you to get inner derivative, you have to differentiate inner to get inner derivative. So the same thing here, outer and outer derivative is not the same. For us to get the outer derivative, we have to differentiate outer to get outer derivative. All right. Now let's solve a question here to understand this properly. All right. We are given a question here, and they said if y is equal to 1 plus s raised to the power of 2, find dy dx. If you look into this question here, this expression 1 plus s is in captive with a power which is 2. So if that is said to be so, it means that this particular function is said to be chain function. Please take note. This particular function is said to be chain function. Please take note. So how do we identify chain function? Whenever we have inner and outer, it means that that particular function is said to be chain function. Please take note. Now let's solve this here. Solution. All right, let's solve this. We say that the dy dx for every chain function is equal to the inner derivative times the outer derivative. So this is the dy dx for every chain function. Please don't forget. So our intention now is to identify the inner from the function or from the equation. and differentiate that inner to get inner derivative. So let's identify the inner here. The inner is the expression inside. So the inner here is said to be 1 plus s. Please take note. So our inner is 1 plus s. The inner is 1 plus s. But if you look into this question, if you look into this formula here, what we have here is inner derivative, not inner. How do I get inner derivative? Is to differentiate this guy here, this inner, to get inner derivative. So let's differentiate this guy. We have 1 plus s, and 1 plus s as a function is polynomial function. So differentiate 1 is a constant. Derivative of a constant is equal to 0. So I'll have this to be 0. That is inner derivative here will equal to plus 0 plus. Differentiate this guy here, this s here. I will have this to be 1. Please take note. So I'll have this guy here to be 1. So 0 plus 1 will give us 1. Okay. So when you differentiate this particular function here is polynomial. So we always differentiate according to the function. Okay, this particular one here, which is the inner here, is polynomial. Okay, in case you don't understand why it is polynomial, please, all you have to do is to hit the subtract button and search for the polynomial function derivative on my YouTube channel. Okay, now let's go to the next one here, the outer. Remember, the first thing we have to do is to identify the outer before we differentiate the outer. How do we get the outer? Remove what is inside. Remove the inside. What is inside? What is inside is 1 plus s. Remove 1 plus s inside this here. Just remove this guy here. Remove this guy. If you remove the inside, what will be left? Bracket open and close, respect to, right? So that means our outer is when we remove what is inside, okay? What is left will be our outer. So I will have bracket open and close, respect to. So how do we differentiate something like this? If I have y to be equal to s respect to, of course, to differentiate this here, to find the dy s of this guy here, I will have this to be, take the power down to the base, it will be 2s. So the same thing applicable to this guy here, this expression here, bracket open and close, respect to. So I will take the power down to the base. I will have outer derivative be equal to 2 bracket open and close. Please take note. Respect 1 because we have to subtract the 2 from 1. When you do that, we have something like this, 2 minus 1. Remember, take the power down to the base, subtract 1 from it, take the power down to the base, subtract 1 from it. So I'll be left with 2 into 2 bracket open, bracket close. 2 minus 1 give us 1. And anything raised to 1 is the base. So bracket open and close raised to 1 will be bracket open and close. Please take note. So we have gotten our inner derivative. We have gotten our outer derivative. So our dy ds here, class, our dy ds here, which is the dy ds for the change function, would be equal to inner derivative, which is the formula, times outer derivative. Class, let's replace. The inner is 1 times, the dot there means times 2 bracket open and close. Please take note. All right, class, 1 times 2 give us 2 bracket open and close. In mathematics, we don't have anything like empty bracket except in sets. And of course, this particular sign here, this particular bracket here is not for sets. Okay, we use curly bracket like this in terms of sets. Okay, so we don't have anything as empty brackets in mathematics. So the question now is, what will be inside this bracket here to make it not to be empty is what is in the bracket from the equation. So look into the equation. What is in the bracket? Inside the bracket in the equation is what? 1 plus s. So our answer will be equal to, class, there's no power attached to this bracket here. So since there's no power attached to this bracket here, I will expand. But if there's power attached to this bracket here, I will not expand. I'll keep it in this way. So I will expand. Since there's no power attached to this bracket, I will expand this. 2 times 1 will give us 2 plus, that is this plus here. 2 times s will give us 2s. So our answer here is 2 plus 2s. All right. Now, all you have to do to get the part two of chain function is to hit the subscribe button, okay?